Hello everyone, welcome. Today our target is to draw level 2 molecules and to identify their shape. This is going to be our last set of lessons on shape that we're going to be covering today. Okay, so just a quick reminder of VSEPR theory. Electrons don't like being near other electrons. Just like the hogs in the hog Hilton, each hog will take its own room first, and electrons are going to take their own place as far apart as possible from the others. Okay, so real quick, let's make an electron dot structure for NH3. Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. And hydrogen has 1. So each of these hydrogen atoms is going to form a single bond with the nitrogen atom. And the nitrogen is going to share one of the hydrogen atoms to create something that looks a little bit like this. Okay, so how do we create the structural formula for this shape? Just like with the tetrahedral molecule we made yesterday, it's going to look remarkably similar. So we've got our nitrogen atom, and we've got a hydrogen atom that's kind of just going at a little bit of an angle, kind of straight flush with the board. And one of these other hydrogen atoms is going to be coming out of the board, and one of the hydrogen atoms is going to be going into the board a little bit. And then there's going to be this unshared pair of valence electrons on top of the nitrogen atom. This creates something that we call trigonal, because there is kind of a triangle going on there, trigonal, pyramidal. Because if we actually create this structure in real life, it kind of looks like a pyramid. Okay? Why? Why would it do that? Well, because electrons don't like being near other electrons. See, this unshared pair, it's kind of creating a sort of electromagnetic force that's pushing the electrons in these bonds away from the unshared pair. And vice versa, the electrons in these 3 bonds, they don't want to be near each other either. Electrons don't like being near each other. And so it's effectively creating a tetrahedral shape. It's just that instead of having a 4th molecule that our nitrogen is being bonded to, it's an unshared pair of electrons. And we call it trigonal pyramidal instead of tetrahedral. I'm going to give you guys a practice problem, and let's see if you can solve it. So for this practice problem, I want you to try PCl3. Go ahead and see if you can solve that. Pause the video, and when you're ready, start it back up and we'll go over it. All right, let's go over PCl3. Once again, I've just kind of drawn all of my valence electrons, chlorine with its 7 valence electrons, phosphorus with its 5 valence electrons. The chlorines are all going to form a single bond with the phosphorus. They're going to share one of phosphorus's valence electrons, and phosphorus is going to share one of the chlorine's valence electrons. Okay, so let's draw the structural formula of this molecule. We'll have phosphorus, and it's going to have 3 chlorine atoms that it is bonded to. Each of these 3 chlorine atoms have 3 pairs of unshared valence electrons, and the phosphorus has a pair of unshared valence electrons as well. And that unshared pair of electrons is why we are getting a trigonal pyramidal shape. Because it's creating an electronegative force that's pushing these 3 atoms' bonds down just a little bit and kind of creating a more pyramid-like shape rather than like a flat shape. Cool. Got one more that we're going to work over.